Okay. For number 1A, we're given 2 points, 2, 6, and 1, 8. We'll call 2, 6 point A and 1, 8 point B. Remember, in order to find the slope, which is the first thing that we're going to find, slope, to make a line, we typically need to end up finding slope, and then we could use a point, and then we can convert it into slope-intercept form. So to find the slope, actually, I just called this AB, but we're going to call it point 1 and point 2. So slope, if you remember, is it's the average rate of change. And so it'll be y2 minus y1 all over x2 minus x1. Again, it doesn't matter what point you call 1 and what point you call 2, as long as you're consistent with, you start with the same point and then subtract to the next point. So as long as you're consistent with that. So my y2 is 8, my y1 is 6. That came from here, 8 and 6. And then we have divided by x2, which is 1, and x1, which is 2, so 1 minus 2. 8 minus 6, we have 2 over 1 minus 2, which is -1. So then our answer is -2 for our slope. Next, although our answer needs to be in slope-intercept form, I'm going to go ahead and write point-slope form first. So point-slope form is y minus y1 equals m times x minus x1. So you just choose one point, and you plug one point in for x1 and y1, and then m is our slope. So we have y minus y1, which is 6, equals m, which is -2, times x minus x1, which is 2. Okay, from here we could go ahead and solve for y, and then we're going to have to simplify to get in point slope and slope-intercept form. So y equals, I'm going to add this 6 to this side, so 6 minus 2 times x minus 2. Next, I'll go ahead and I'll distribute my -2. So we have y equals 6 minus 2x plus 4. 6 plus 4 is 10, so y equals minus 2x plus 10. And that's your final answer for A. Any questions there? Okay, for problem B, we're already given the slope. The slope is 6, and it's passing through this point. So we don't need to find out what the slope is. All we need to do is go ahead and plug it in point slope form and then solve for y. So we have, again, y minus y1, so y minus 2 equals m, which is the slope, 6 times x minus x1, which is -5. So minus -5 is +5. Okay, go ahead and put that in point slope form. So y equals, add 2 to this side, 2 plus 6 times x plus 5. Y equals, distribute this 6, 2 plus 6x plus 35. Oops, 30. Add the 2. Y equals 6x plus 32. And that's your answer for B.
I have a question. Couldn't you, I feel like an easier way would be just plugging the x and y coordinates in to solve for B. Like, is that fine to do too?
That's I actually, as a student, I always preferred that way. You could totally go through that way. And that's perfectly fine. So anyone that wants to do that can do that. if someone wants me to walk through one that way, I would gladly do it. Just as an instructor, I like to kind of stick to one way. I do find that more students prefer the way I'm doing, but either way you want to do it, you can, as long as you get to the answer. But if someone needs me to walk through it that way and wants to see that way, I will gladly. Just let me know. Next is, we're gonna do E together. So for E, we have to find, are we gonna do E together? I'm actually gonna not do E with you guys right now. E, I just want to let you know that, right, each of these is a point. So here, the X value is 2 and the Y value is -5, so it's 2, -5. And then here, the X value is 4, the Y is 0, so we have 4, 0. Those are your points. That's kind of the trick for that way. Yes, I'll do one. What one do I want to do? Yeah, I'll do. What one? I'll do E with the other way, because that's the best one to do the example with. So E, so this is the way that you're going to put it in, use the point and the point in the slope, and then you're going to solve for B, so solve for the y-intercept, and then you'll go ahead and plug it into the equation. So we have the points 2, -5, and 4, 0. So to find our slope, I'm going to call this first one is 0.1, and this second one is 0.2. So y2 is 0, minus y1 is 4. Oops. Minus y1 is -5. So 0 minus negative becomes a +5. Y2 is, x2 is 4, minus x1 is 2. Sorry, guys, I cannot talk apparently. So here we have 5/2, and that's your slope. You can leave it in a fraction, put it in decimals, it doesn't matter. I'm going to leave it as a fraction because it's a nice enough fraction and we don't really have to do much with it. Okay, so then we have y equals mx plus b. We're going to choose a point, and I'm going to choose the point. I'm going to choose 0.2 because it has a 0 and it's nice to work with zeros. So 0 equals 5/2 times 4 plus b. Okay, so 0 equals 4 divided by 2 is 2, so 10 plus b. So that means b equals -10. So then we have y equals, m is 5/2, x plus b, which is -10. And that's your solution there. So you could also do it that way. Any questions on that? Okay. Next, we'll do G. So G, the horizontal intercept is -2, is at -2, and the slope is 3. So that means the horizontal intercept is the point -2, 0, and we have slope is, what did I just say, it was 3? Okay, so here, it's nice that we have a 0 point. I'm going to go ahead and use point slope form. So we have y minus 0 equals 3 times x minus -2 is +2. Okay, so then all we have to do on this one is really just distribute out that 3. So we have y equals 3x plus 6. Any questions there?
Wait, so where'd you get the +2? Was it because the horizontal is -2?
Yep, it's because this the horizontal intercept is -2, and then it's x minus -2, so it becomes +2.
Oh, thank you.
Yep. All right, next we'll do I, and that'll be the last one we do for this section. The vertical intercept is 3, and its horizontal intercept is 7. So that means we really have 2 points. They're just saying it in a weird way. So vertical intercept is 3. How do I want to do this one? We can actually, there's a couple ways you could do this. You could find the slope as you typically do, or we can go ahead and just plug it right into slope intercept form, which I think I'll do that way. So we have y equals mx plus b. All right, and then we know that the vertical intercept, so here m is the slope, b is the vertical intercept. So we could go ahead and just plug that right in. So we have y equals mx plus 3. And then we can use the horizontal intercept, which is the horizontal intercept, to plug that in. So the horizontal intercept is 7. So we have 0 equals m times 7 plus 3. And we could go ahead and solve for m. When you do this, you get -3 equals 7m. M equals -3 divided by 7. So then plug that into our equation. So we have y equals -3 over 7 x plus 3 as your final answer. Okay. Any questions there?
Oh, never mind.
Okay. I'll give you guys another second to copy that down. All right, on the next page, we're going to do most of problem 3 together. Problem 2 is for you to do on your own. I'm going to give you a hint. So problem 2, which of the following is not a graph of the linear function? So you have to make sure that it's a linear equation, but also you have to make sure that it's a function. So remember, it has to pass the vertical line test. So when you go through this one, make sure you're paying attention to both of those words. They're both very important. Problem 3, we're going to do A, B, and C together. D and E I will leave for you to do on your own. The value of an antique lamp V of T in dollars T years after purchase is given by V of T equals 1,900 plus 250 T. Part A, write a complete sentence explaining the practical meaning of the vertical intercept of this linear function. Include units in your answer. So part A, our vertical intercept tells us at time 0, so that is when the lamp is first purchased, tells us at time 0 what the value of the lamp is. So when the lamp is first purchased, it is worth $1,900. Okay, this one's, I want you to remember when you're doing this one that it can be a little tricky to think about, because, you know, typically you buy something, like in all of our examples, when you buy a car, we talk about how the value decreases as time goes on. But since we're in this example, we're talking about an antique lamp, even after it's purchased, the value continues increasing. So I want you guys to pay attention to that. B, write a complete sentence explaining the practical meaning of the horizontal intercept of this linear function. Include units in your answer. So the horizontal intercept is when the value of the car is worth nothing. So I mean, sorry, the value of the lamp is $0. And because the lamp is an antique, this happens prior to purchase, okay? So T is actually negative in this case. So it's before the lamp was purchased when it was worth nothing. So the horizontal intercept is the year prior to purchase that the lamp is worth $0. It has a value of 0. Any questions on that one? Okay. Part C, write a complete sentence explaining the practical meaning of the slope of this linear function. So the slope is positive 250. So the slope is telling us that, and it's being multiplied by time, by the amount of years. So it's telling us that every year after purchase, the value of the lamp increased $250. So every year after purchase, the value of the lamp increased $250. Any questions on that? Please make sure anytime I'm asking you guys to describe the practical meaning that you're writing in a complete sentence. It's really, one, it's literally a sentence. It's not like I'm asking for paragraphs of explanation and analysis. Two, it just stating what the units are of each variable and whatnot doesn't show me that you're understanding the concept behind all this. And again, this is the applied pre-calculus course, so please make sure you're using a complete sentence. All right, and then we're going to do all of the last page together. So problem 4, 2 mobile phone companies sell an international roaming plan. Company A charges $75 fixed monthly fee with 20 cents per minute for talk. Company B charges $90 fixed monthly fee and 10 cents per minute for talk. Part A, write the linear functions A of M and B of M, which give the monthly cost charged by company A and B respectively, with M minutes spent talking on the phone. Okay, so write the linear functions A of M and B M. So what these values are telling us here is if there's, so for company A, let's say, this $75 fixed monthly fee, you pay no matter how much you talk on your phone. So that's actually your your y-intercept. And then this 20 cents per minute of talk is going to be your slope, because every minute you talk, you're going to multiply it by 20 cents. So our function for company A, so A of M is equal to 75 plus 0.2 M. Similarly, for company B, our fixed monthly fee that we're going to pay no matter what is $90 per month, but every minute we talk on the phone, it's only 10 cents. So our slope is only 10 cents. So 90 plus 0.1 M. Company B, question B, for which value M is the cost the same with either company? So we're trying to figure out if you talk on the phone for how many minutes is the cost of each company equal, right? Because just by looking at these, you can see that if you don't talk on the phone very much, it seems like I'll go back at the end of this page for you. If you don't talk on the phone very much, you're paying a high monthly fee, but maybe you only talk on the phone for 1 or 2 minutes, so maybe it's not worth it. But if you talk on the phone a lot, and you go with company A, you're paying $75 initially, but you're spending double per minute of talk, right? So we'll see mathematically when we get to see which plan is better for if you talk on the phone a lot. But initially looking at it, it's kind of hard to tell. But maybe you have a gut reaction, a gut instinct. So part B, so we're going to find out where the companies are cost the same. So per month, they'll cost the same if you talk how many minutes. So we're going to set these equal to each other. 75 plus 0.2 M is equal to 90 plus 0.1 M. Okay, so subtract 0.1 M, subtract 0.1 M. We have 75 plus 0.1 M is equal to 90. Subtract 75 from both sides, so you have 0.1 M is equal to 15. Divide by 0.1, divide by 0.1, M equals 150 minutes. So if you talk on the phone for 150 minutes each month, or in a month, the cost for company A and B is the same. Okay. Next, question C. There's a couple ways we could do this. We could do this just by looking at the numbers. And if you want to just look at the numbers, plug in any value over 150 and see which is higher and compare. So if I plug 200 in, so A of 200 is equal to 75 plus 0.2 times 200, which is equal to 115. And B of 200 is equal to 90 plus 0.1 times 200, which is equal to 110. So the question is, which company gives you a better deal if you plan to talk for hours? Oh, sorry, all my units are wrong. Hours. Oh, no, my units are right. The question is just emphasizing that if you plan to talk for a very long time on the phone. So if I plan to talk for a very long time on the phone, these two graphs intersect at 150 minutes. So that means that whatever one is higher after that is going to cost more. So I would go with company B. So company B. Right back there. Okay. Another way you could look at it is by graphing it. Okay, so you could use either a graphing calculator or Desmos. You just go here to desmos.com, graphing calculator. Here you could plug in your functions. So our function is, let's see. Okay, y, sorry, I've never used it on my iPad. For company A, we have y equals 75. Oops, not x. 75 plus 0.2x. Enter. It should just pop up here. I don't know why it's not. And then we have y equals 90 plus 0.1. Oops. Plus 0.1 x. Oh, there they are. Okay. So we see that, of course, I don't have a pointer, but we see if you could find the point 150, find where x is 150, it's just over 100. So like maybe $105 or something. But this red line, after the point 150, this red line is higher than the blue line. So that means that if you're going to plan to talk for a longer amount of time, the graph modeled by the function modeled, the company modeled by the red graph is going to cost more. And our red graph was, of course I can't, oh, here it is. Our red graph was company A. So just as we thought, company B is cheaper in the long run because the blue line is below the red line as time goes on, even though it initially starts out a little higher. All right. Okay. Lastly, problem 5. Say that solve the given linear equation. If there's no solution or infinitely many solutions, say so. So part A, we have -2 times x minus 3 divided by 5 equals x plus 1. All right, so we're going to go ahead and solve this. The first thing you do is multiply both sides by 5. So we have -2 times x minus 3 equals 5 times x plus 1. On the right-hand side, we could go ahead and distribute out this 5. And on the left-hand side, we could distribute out the -2. So we have -2x plus 6 equals 5x plus 5. Next, we'll go ahead and combine like terms. So I'll add 2x to the right-hand side. So we have 6 equals 7x plus 5. And then I'll subtract 5 to the other side. So 6 minus 5 is 1 equals 7x. Divide both sides by 7, and we end up with x equals 1/7. So we can solve it and it's fine and dandy and we're good. Any questions on part A?
Do you just take the 5 and just move it over? And that's just like,
I subtracted it from both sides, so here I did -5 minus 5. 6 minus 5 is 1.
oh, I meant, sorry, the 5, like in the way beginning.
Okay, so here I multiplied both sides by 5. 5 divided by 5 is 1. And then I multiplied this side by 5.
Okay, I forgot that you could do that. Thank you.
Yep, no worries. All right. Part B, we have 3x minus 7 equals 5 plus 3x. I'm going to show you two ways you could go about this. You could just look at it and you could say, you could notice maybe that the coefficient for x, the number in front of x, is the same, but the constants are different. So coefficients are the same, but constants are different, which means no solution. Or if you'd rather just kind of solve it and see what happens, when you look at this, you have, we have 3x minus 7 equals 5 plus 3x. If I go ahead and subtract 3x from both sides, right, I'm going to pretend like I'm moving that over there. So minus 3x minus 3x. You end up with 0 minus 7 equals 5 plus 0. Right, so all the 3x's cancel out. So we have minus 7 equals 5. This is not a true statement. Not true. So we have no solution. Lastly, part C, we have 2x plus 2 equals 4 plus 2 times x minus 1. All right, so on this right-hand side, let's distribute out this 2. So we have 2x plus 2 equals 4 plus 2x minus 2. Okay, let's combine our like terms. So we have 4 minus 2 to combine. So we have 2x plus 2 equals 2x plus 2. The equation is the same on both sides. So our variable coefficient is the same and our constant is the same. So coefficient and constants match on each side. So we have infinitely many solutions. Alternatively, if you did want to keep solving it, so if I brought this down here, we have 2x plus 2 equals 2x plus 2. If I go ahead and again subtract the 2x's from both sides, minus 2x, I end up with 2 equals to 2, which is always true. Which again tells us infinitely many solutions. Any questions on this page? Okay, do you guys need another minute to write down the stuff on this page? That way I could go back to number 3.